VLSos here. This is a pre-algebra video lesson on area model for multiplication. I have an example written here already. I'm multiplying 2x plus 1 times x minus 3. This is a pretty difficult multiplication problem. There are many ways to organize and produce an answer for something like this. The technique that I'm going to show you is a good one because it's a visual strategy. The area model for multiplication is a visual strategy for multiplying anything. And what we're going to start with is multiplying two algebraic expressions. It's visual because it's a way of organizing it in a way that we can produce the answer by starting with a rectangle. And I'm going to put on the sides of the rectangle the things that I'm going to multiply. I'm multiplying a 2x plus 1. I'll write that on one side of my rectangle model. I can think of the plus 1 as a positive 1. If I have two terms in this expression, then I want to divide my rectangle into two columns. One column for each expression. The x minus 3 is the other thing that I'm multiplying, and I'm going to put it on the side. There's two terms, an x and a minus 3 or a negative 3. And since there are two terms, I'm going to divide this side into two rows. We could see that we have the two expressions that we're multiplying on two different sides of the rectangle. And then the rectangle has been separated into rows and columns, a row or a column, one for each expression. Now I'm going to busy myself finding the product of just those terms. So if I wanted to find the product of 2x and x, I do that math, which is simpler than the entire multiplication problem. It's just a piece of it. 2x times x is 2x squared. And I write that piece inside of the rectangle, the smaller rectangle that has those sides. This rectangle here, I'm going to produce a part of the answer. What I'm going to put inside this rectangle is the product of its sides, the sides being 1 and x. 1 times x is just x, and I put that product inside that box. The product that belongs in this smaller box is the side 2x times negative 3. 2x times negative 3 is negative 6x. And inside this smaller box will be a 1 times a negative 3. I'm multiplying the sides. 1 times negative 3 is negative 3. So you might have caught on that the product of the sides of the original rectangle has been broken into subproblems. I found each of these four pieces, so to find the product overall, I need to collect those pieces. Now I'm going to write those pieces on a line below, the 2x squared and the positive x and the negative 6x or minus 6x and the negative 3 or minus 3. So I've listed those pieces, I've collected the boxes, I have this expression, but I can take one last step. I can combine like terms. The 2x squared doesn't combine, but a positive x and a negative 6x combine to be a negative 5x, and we have the negative 3. I'm going to put a box around my final answer. This is a visual strategy because I'm using boxes and sides, and I'm using it to focus on just a piece of a problem at a time and collect the answer in the end. I'm going to do this again, but it's going to be more abstract. I'm going to multiply two expressions, but in this case it's just going to be variables or letters that can stand for more complicated expressions. A plus B times C plus E. And just as before, I start my model with a rectangle. I write on the sides of this bigger rectangle the two expressions that I'm going to multiply. In this case, an A and a B. And then the C plus E gets written on this side. I divide one side into two rows because there's two expressions, and this side here into two. The A and the B are in columns, and the C and the E will produce rows. Now I find the products of the smaller rectangles inside based by multiplying just those sides. So here we have an A times a C, or AC. Here we have a B times a C, or a BC. Here we have an A times an E, or AE. And here we have B times E, or BE. And the final answer is the sum of all these little rectangles. AC plus BC plus AE plus BE. It's called an area model because the product that we're trying to find is the sum of these pieces, as if the pieces were a part of the area of the larger rectangle that we began with. And in this expression, it says we can multiply anything. We can. If there was another expression to multiply, if there are more than two things to multiply, like a third group, then what we could do is we could find the product of the first two with an area model and then use the area model again to find the multiplication of our answer and a third thing. And we can continue to use the model to multiply more and more things if we needed to.